first learn cross multiplication? Okay, middle school type stuff. And then you revisit in geometry a little bit. So that's where we're going to be working with today, cross multiplication. Before we get to the actual solving parts, I want to do something. You guys remember when we had extraneous solutions last unit, where we solved using square roots, cube roots, and at the very end we get solutions you always have to check to see if they'll work or not? And that's still going to apply here, but it's going to be more specific to restrictions. Remember how we say there's some numbers that aren't allowed in the denominator? Those are numbers that would cause division by 0. That's what we're going to be looking for in these situations, because sometimes you have x's that won't work. They're extraneous. So I have two questions here. I have one situation where I'm asking if -1 is the solution, and another one where I'm asking if -3 is the solution. How do you think you would check if they have this kind of question? They're not asking you to solve. They're just saying, here's a number, would it work? You do what? Plug it in. So let's see if -1 will work here. So we're going to plug it in. So 3 times -1. And we have -1 plus 1. We want to know if these two are equal. That's a 2, sorry. By the way, anytime you guys are plugging in something that's negative and you're squaring it, always make sure you guys have parentheses around that number anytime you guys are plugging it in, especially when it's negative. So let's see what happens here. If I have -1 plugged in, what happens in the numerator here when I multiply those? -3. What happens in the denominator? 0. Can I divide by 0? If you try doing -3 divided by 0 in your calculator to see if these two are going to be equal, your calculator is going to say error or domain or some sort of error message they're going to give you. So would -1 be a solution? No. -1 is a restricted value, just like we've been finding restrictions before. Do you guys remember how to find restrictions, by the way? You look at the denominator and you set equal to 0. So if you had done that here, if you had looked at x plus 1 and said equal to 0, you would have known that -1 wasn't going to work anyway because it was a restriction. So that's why we have restricted values, because they cause a situation where you're dividing by 0, which can't happen.
Is there a line?
That's a 0. I just do that because my O's and zeros look similar. Just like when I draw Z's. My Z's look like 2's. Hold on. No. There, that won't move. It's lock and place. Alright, so yeah, I draw my Z's like this sometimes so that they look different and cheap. Anyway, so that's how you guys can tell something's a solution or not. It's a restricted value or you don't get the equality to work. What about this one? What if I wanted to know that -3 was a solution? Plug it in. So 5 times -3 divided by that. I want to know if that's the same as this. Alright, so take a second to evaluate that and see if they work out.
Isn't that harder with the smartboard?
Yes. It's actually kind of irritating. Alright, so what happens on this side? You get -15 divided by, okay, so it's -15 divided by -5. And then we have the 7, and then what happens over here? We have 10 divided by -5, which is -2. Then we have 7 minus 2, which is 5. So would -3 be a solution? No. It wouldn't. Because is 3 equal to 5? No. So this one was not a solution because it was a restriction. This one's not a solution because we don't have equality. So there are two different ways to have non-solutions. It's when it's a restriction, or if you plug it in that the equation doesn't hold. So two different ways you guys can have non-solutions. So just in case you guys run into that. All right. So we have two types of equations we're going to be solving. I call them type 1 and type 2. Kind of boring. But type 1 is where you guys have one fraction is equal to one fraction. So it's a one-to-one relationship. This is equal to this. You guys can see that with all 4 of these examples. You have one fraction is equal to one fraction. If you turn the page and look at the examples on the other side, those are type 2. It's where you have multiple fractions equal to one fraction or multiple fractions. There's only one extra step to that. It's just you have to take the fractions that are added or subtracted. You have to actually add or subtract them first, so it's one fraction. Then you do cross multiplication like we're going to do here. So it's one extra step to combine the two that have been separated with addition or subtraction. Alright, so the process here, I've outlined it in 3 steps. Okay, so you're going to state the restrictions. State the restrictions on the domain, because the x values are what we're worried about, for values that are not allowed, and x's are in the domain. Once you know what the restrictions are, we're going to cross multiply and solve for x, and then we're going to compare solutions to restrictions. If any solutions that you get are a restriction or part of the restrictions that you guys find, then you would reject that answer. So always find the restrictions first so you know how to compare your answers once you finish. Okay? So let's take a look at this first example. I'm going to start easy and then kind of go a little bit further from there. So the first thing I want to do is know what the restriction is, what x cannot be. And how do we find that again? You look at the denominators and you set them equal to 0 to know what x's are not allowed. I only have one x, which is right here. If I set 2x equals 0, 0. Remember, monomials give you restrictions of 0. So the one answer that I cannot have is 0. Right, that would fail because it's a restriction. Alright, so let's go ahead and cross multiply. Do you guys remember how to do this?
Yeah.
You're going to multiply these two together. And then you're going to multiply those. So you get 12. How do you finish solving? Divide by 2. Alright, was that the restriction? No, so then this would be your answer. Simple enough, right?
That one gets harder.
Just a little bit. Just a little bit.
Just a little bit.
Just a little bit.
Oh, no.
Alright, moving over to this one. Where do you look for restrictions? Are there any x's in the denominator? No. So there are no restrictions. None. It's not 0. Not 0. It's not the number 0. It's just there are none. Okay? Alright, cross multiply. So I'm going to multiply these two together. So I get 3x. 5x plus 20. You have to remember if there are two terms, when you have to distribute when you cross multiply. So the 5 is being multiplied times the x and the 4. Be really careful you remember that distribution. Then what? So you would move the 5 over here, and then divide by 2. 10. There were no restrictions, so I don't have to worry about negative 10 numbers. Right?
Yeah.
Sorry, divided by negative 2. Sorry. That's where the negative 10 came from. Okay? Now these are the ones where they're going to look a little bit more like algebra 2. Right? Those were a little like algebra 1. These are more algebra 2. Alright, so again, restrictions. Where do I look for them? Okay, so there's only one denominator with an x, so 4 is not allowed. Because if you set this... Yeah. Okay. Alright, now we're going to cross multiply. So if I multiply these two together, alright, but when I multiply these together, it's a binomial times a binomial. Let's write it like this. You have to FOIL. No. No, it does not. Alright, so when you have a binomial times a binomial, we're going to have to FOIL. So x times x, x squared, x times 5 is 5x, and then you have negative 4 times x, which is negative 4x. If you add those together, you only have a positive x. So when you do FOIL and then simplify it, you should get x squared plus x minus 20. Subtract the 10. Why would we subtract the 10 over? If you see a trinomial, how are you going to solve with a trinomial? You factor. In order to factor, don't you have to have everything on one side?
Yeah.
Yeah. So that's why we move the 10 over, just like Justin was saying. So now I have this. How would I factor a trinomial? My x trick. So what goes in the top? And then in the bottom? Okay, so what multiplies to get negative 30 that adds to get 1? Yep, 6 and negative 5. Okay? Can I use the shortcut in this situation?
Yeah.
Why?
There's a 1 in front of that.
There's a 1 in front of the x, so I can use, it's a positive 1, yep. If it was negative, there would be a different situation. And then you set them equal to 0 to finish.
-6 is 5.
Negative 6 and 5. There you go. That's not too bad.
I kind of got lost in the FOIL, so I got the x squared.
So I do the FOIL and the simplify kind of at the same time. When you FOIL, you would get 5x and negative 4x. So I kind of keep that in my mind and I combine them together at the same time. 5x minus 4x is 1x. If you need to do all the work out, that's fine. Okay, I'm gonna let you guys try this one on your own. Give that one a shot.
So at first, I don't make sure I try to do 2x times the 1x, so 2x squared. Then you do 2x times the 6, plus 12x.
Yeah, I'm trying to know how you solve. You can factor in, so.
It's only 1. So
Yeah. So it was 1 is not 2. So, can we use the shortcut to do it? No, so we're going to do the factoring of that forms. So we factor this 2x squared minus 5x minus 2x.
Oh, because you're more visual. Yeah, so I got that, right? So I got that. And I contracted it. And I got it. And then I go to 12 over here.
Great. Anybody like to help describe how we would work through this process? Yeah, just describe it. Great. Okay.
The next time you get 2x to the second power plus 12x.
Okay.
And you subtract you move 7x equals 7 to the other side,
Alright,
and you get 0 equals 2x to the second power plus 5x minus 7.
alright, so pause for a second. When you realize that you have an x squared, an x, and a number, that's a trinomial, and you have to solve trinomials by factoring, so it all needs to be on one side. Okay, keep going.
And when you factor this, you have to multiply 2 and negative 7. So negative 14 is on top and 5 is on the bottom.
Okay.
You get 7 and negative 2. And so you, I don't know what it's called, but you have to get grouping.
Okay. So, one second. Can I use the shortcut that we've been using? No, because there's a 2 in the front that you can't get rid of with the GCF. So we have to go back to how we were factoring before, which is where you split the middle term into these two numbers. Alright, and you factor by grouping, just like Michaela was saying. So I'm going to have plus 7x minus 2x and then minus 7.
Just go through it and you would put the 2 on the outside and distribute.
No, because 2 is not a GCF. 2 is not a GCF though. So you can't extract the 2. So then, Michaela, do you know how you would go from here?
Yeah, I did it the opposite, but from there you can.
Oh, you mean you had the other side? Sorry.
But from the left side, you can take out x.
Okay.
You get 2 plus 7. And from there you take out
A negative 1. When you guys don't see an obvious GCF, remember it could be a 1 or a negative 1. When you have the negative at the front, you have to pull out the negative 1. So to finish factoring, I would have this. We pull the 2 outside numbers together and then the 2 insides, which should be the same. If you factored it correctly, those stay. And then you're going to set those both equal to 0.
1, and then
And then negative 7. Alright, so you guys still need to remember how to factor not using the shortcut. Alright, don't lose that strategy now that you have that shortcut. You have to remember when you can use a shortcut and when you can't. Yes.
Okay, so I got confused. Okay, so like I got it, but like, so you know the second step is like 0 equals 2. So like, how did you get where's that extra 7 go?
So this 7 right here. See how we have 7x plus 7?
Yeah, exactly. Subtract the 7x over to the other side, right?
Gives you the 5. And then you have to subtract the 7 to cancel it as well. So that's negative 7. Alright? Is everybody okay with the first type? Cross multiply? Yes? Alright. Now we're going to look at the type 2. Type 2. These ones where you have more than one fraction on one side. Typically it's like 2 and 1 or 2 and 2. You're not going to have more than 2. The directions here are a little bit different than I want us to use this year. I've tried one method last year and it just didn't work out. So the directions here are not going to be what we're going to do for this year. What I just said before we started, what we're going to do for the type 2 is we're going to add the fractions together so that it's 1 to 1, so it looks like what we were just doing, and then cross multiply. Right. That's different than what this says. So I'm gonna. I know we're not gonna really fill it in. So if you guys want to take notes, just say we're gonna add them and then cross multiply. That's basically the summary of what we're gonna do. Add them and then cross multiply. So we're basically gonna do what we just did last time. We still need to find restrictions and everything. But if there's addition or subtraction, we're gonna go ahead and take care of that and then cross multiply. Alright, so we're going to find restrictions first, just like we did last time. So look at your denominators. There are no x's, so there are no restrictions. Alright, so then I have two situations where we're going to need to add my fractions together. So we're going to use what we did last lesson. We need common denominators on this side. There are two separate questions. So the common denominator over here can be different than the common denominator over here. We have two separate situations that we're working with. So if we kind of just split it, right? If we look over here, we have 4 and 6. What should the common denominator be over here? 12. Okay. So then how do I... Okay, so this one would be times 3, so I have 3x over 12. Okay, so 4x over 12. And then you add them together, so that would be... Alright, Alright, so up here, I'm going to rewrite the question up here. So 7x divided by 12, right, like that. And then the second half, what would the common denominator be over there? 8. If you want to write a little note above common denominator for the second, or the right side of the equation, that would be 8. So what would I do to the first fraction? Leave it. So 5x over 8. What about the second one? Okay, so 2 over 8. And if I add those together, what would my new 5x plus 2, so not like terms. I'm sorry.
Wait, why'd you multiply that then?
Because I needed both of the denominators to be 8 in order to add them. So to go from 4 to 8, I multiply times 2. Alright, so I do the work under here, and then I write the new question right here. So now this is what I'm going to be working with. I have 1 to 1, just like we saw on the previous page. Now how would I solve this? I would cross multiply. So I'm going to multiply the 7x times the 8. 56. 56x. And then I have the 12 times the 5x plus 2. 60x plus 4. Anyway, so what would I do now? Move this over. So then that would be negative 4. And then divide by negative 4. So your answer is?
Negative 6.
Right there. So if you have fractions that are needing to be added or subtracted, just do that first, and then use cross multiplication. That make sense? Okay. For this fraction, right, find restrictions first. What number would not be allowed? 0. You look at your denominators, they're monomials, and monomials give you restrictions of 0. Right, so 0 would not be allowed as a solution. So let's look at the left side of the fraction here. The right side's fine. That's just 1/3. That's fine. But over here on the left side, I have 2 fractions that I need to combine. What would the common denominator be in order to add those two? 3y. You have the number and the variable part. The number that they need to have in common is 3, and the variable they need to have in common is y. So I need the common denominator to be 3y for both of them. The first fraction's okay. What? How? Come back. Alright. That's a 2. And then what's wrong with the second fraction? Okay, so 12. So if I add those 2 fractions together, what would I have? 14 over 3y equals 1/3. The fraction on the right side of the equation was fine. We only have 1. You cross multiply, since I have 1 to 1, like we had on the previous page. So if I cross, what is that? 42. 42. Yep.
14.
Is that my restriction? Alright, seeing how that works? There's one of these that you guys are going to really hate, so I'm going to make sure I do that one with you. Yeah, okay, you're going to hate this one. Yep, I'm just warning you. Alright, so for this one, do I have anything to worry about on the left side? Nope. That one's already... Say again? Oh, okay. On the right side of the equation, though, I need to combine these 2 together. So what do I need the common denominator to be?
4.
It needs to be a 4. So the first one already has the 4.
Yeah.
But the second one, it's a 2 right now, so I need to multiply times 2 to get to 4. So if I add those together, 5x plus 2 over 4. So this is my new situation. Instead of going from the type 2, I turned it into a type 1, so it's 1 to 1. So now, cross multiply. So if I multiply the 1 and the 4, and then if I multiply x times 5x plus 2,
5x squared. Minus.
Now, this is a trinomial, right? I have an x squared, an x, and then a random number.
Subtract the 4 over.
You need to move the 4 over.
Oh my gosh.
It needs to be all aligned in standard form, so you move the 4 over. And then what do you want to try to do? Okay? So then you have to multiply the first and last numbers together. 5 times negative 4 is negative 20 and 2. What numbers multiply to get negative 20 but add to get 2? None!
Oh, wait, you can use the.
Oh, factoring will not work.
I'm not gonna quadratic.
Yes, you are.
No.
Factoring does not work. So if factoring does not work, you have to use quadratic formula.
You got Mary.
I wrote it right there. It's in the second box. It'll be up there, so you guys can use it.
Oh my gosh. What is this?
Quadratic formula. I hope that you would recognize it by now. So x equals negative b. What is b? 2. So it's going to be negative 2 plus or minus square root of b squared, which is 2 squared, which is 4, minus 4ac. So it's 4 times 5 times negative 4, which is negative 80. Sorry. Yeah, so you're subtracting a negative number. If you were to multiply 4 times a times c, you get negative 80. You're subtracting it. So what happens when you subtract a negative number? You're really adding it. You have to be very, very careful. You guys have the signs, right? One thing that I do recommend for some people is to actually put all of that in your calculator once, like type b squared minus 4 and then a and c, like what the numbers are in your calculator. So you get it all at once, so you get that full number using your calculator to help you. That can sometimes be helpful. And then in the bottom is 2a. 2 times 1, and a was 5. Alright, so in order to use the quadratic formula effectively, you guys need to shrink the number inside of the radical to just 1. So what is 4 plus 80? 84. Now, this is something that you guys have to be very, very careful with. I know you guys see that the 2, the 10, and the 84 all can be divided by 2, right? So can you just divide by 2? No. You cannot cancel. Cancel is at the very, very end. There's a very specific order for quadratic formula. You shrink the number inside of the radical to just one number, then you simplify this, then you can cancel. Cancel is at the very, very end, right? So think back to unit 5. You just split the 84. Is there a perfect square that might be inside of the 84? There's.
4.
I don't think 16 goes in evenly.
4 is a perfect square.
4 is a perfect square, isn't it? Does 4 go into 84?
4 and
Yeah.
So Brigham was with the 16. If you're thinking about higher perfect squares, you want to know if they work or not. You would do 84 divided by that number, and you would get a decimal. So that was not going to work. So the only two numbers that I can split it where one is a perfect square is 4 and 21. Okay. So if I was going to simplify the radical, what would it look like? What happens to the 4? Do I just pull out a 4?
No.
So 2 on the outside, right? 2 on the outside, 21 on the inside. Now you guys are free to cancel whatever you want. Is there anything that all three of these things have in common?
2.
2, so I can divide by 2. So if I don't want to make this too messy, but if you slash through those and divide by 2, you're going to have negative 1 plus or minus the square root of 21 divided by 5. Yes, because we had negative 2 before. If you divide that by 2, it's a negative 1 left behind. That's your answer.
Wait, you didn't do the real number.
I didn't do the restrictions, it's 0.
What is this?
You feel like that one's good.
I don't remember.
What's the big number right there? Is X?
Yeah, this one right here. If you plug into your calculator, it's actually not that big of a number. Alright, so I put this in here so you guys are prepared in case you see quadratic formula. You guys have to remember that factoring is not always what you guys use to solve. If you can't factor, you have to use quadratic formula. Alright, Let's try these next ones. A little bit more complex. Let's start with restrictions. That's the easy stuff, right? So what would my restriction be, or restrictions if there's more than one? 0 and -1. Neither of those numbers are going to be allowed. Okay, this is one of the just a little foreshadowing. Well, plot. Spoiler alert. For this one, when you guys have two restrictions, that's typically the situation where one of them is going to show up and you'd have to say it's not a solution. So when you guys have two restrictions, that is typically the situation where one of them, when you get the answer, is going to be an excluded restriction, or sorry, an excluded answer because of the restriction. All right, so I like to do this so I can separate what's going on here. Is everything okay with the left side?
No.
No, I need to combine them together. And we have to look at the common denominator. So the common denominator should have an x in it. It should also have an x plus 1. Remember, common denominator is supposed to have one representative of every factor that you see. And these two, I have an x and an x plus 1, so both of them need to have both of those things. So the first fraction is fine. But yeah, this one's missing the x, right? So I have to multiply top and bottom. Alright, and if I combine those together, what would it look like? What would it look like in the top? It doesn't really matter what order you guys write them in. We'll fix it a little bit later, but it would be 3 plus 3x. And then in the denominator, in order to help us along with the process, you do want to multiply out the denominator, so it'll help us in the process. So instead of writing x times x plus 1, x squared plus x. So to help us along with this particular situation, you do want to distribute. In regular add or subtract, I don't need that. But when we're trying to use this as a step towards solving, you do want to distribute or whatever you guys need to do in the denominator. So it's one expression instead of something factored. Because it would be hard to multiply, right? If we didn't have this expression written like this. Is there anything wrong with the left side? Or sorry, the right side. That's one fraction, so I can just rewrite it. Negative 1 over x. Alright, so now I have 1 to 1. So now how would I cross multiply? So you can either attach the negative to the x or the 1, it doesn't really matter, you just attach it to one of them. You want to attach it to the 1? Okay, so we're going to pretend it's attached to the 1. So then if you multiply these two together, okay, and then if you're going to attach the negative to the 1 and then multiply those, you would have minus x. So you distribute that negative through the entire expression. Everybody see how we got to that point? Questions up to there? If it's in the wrong order initially, you can fix that before you factor. So it can be a little bit sloppy as you're getting to where you need to be, but then you can take care of that right now. So, see how I have an x squared and an x, right? I want everything to be on one, in order to solve, you need everything on one side and a 0 on the other. So I'm going to either move everything over here or everything over there. You want to go over here? This way? Okay, so then we're going to be adding an x squared, and then we're going to be adding an x, and I'm going to go ahead and write them in standard form. Like that. If you add 1, it becomes 4x squared, and if you add the x, it becomes 4x. I'm just going to go ahead and write them in standard form. I'm going to swap the order there. And that's okay because they're both positive, so it doesn't affect the signs. Right, so this is not a trinomial, right? So I wouldn't factor using the x trick, but I can still factor it with a binomial. You can use a GCF. So 4x, x plus 1. Like this. So even though this is a monomial, you can still set that equal to 0 and solve. I have two x's, so I'm going to have two answers when I'm solving. So if I set 4x, I would get 0. So I would get 0 as one solution, and then negative 1 is the other solution. So what in the world is going on here? Both of those fail. So what do you think?
No solution.
No solution.
Oh,
I know, after all that work.
No solution.
Yeah. No solution. So if you get to a situation where both of your answers are the restrictions, that means that there are no solutions. If one of, so if I had like 0 and positive 1, you would just cross out the 0 and say the solution was 1. So sometimes just one restriction is going to show up and you would just exclude that. But if both of them are restrictions, no solution. Alright? Alright, let's do this one a little bit faster so you can finish in time. Let me extend the screen a little. Alright, this one is a little interesting. Alright, is there anything I need to change about the left side here? Yeah. I'm going to have to get the common denominator,
Yeah.
x plus 5 and x minus 5. You can do a little bit of a mental kind of factoring here. X squared minus 25, you can factor that to x plus 5, x minus 5, right? So your LCD, your common denominator, needs to look just like that. X plus 5, x minus 5. Like this, if you kind of visualize that in your brain when you factor that. You do want to keep it multiplied together though. Alright, so when we're working with this, you don't have to write the common denominator this way. We're going to pretend that we're factoring or foiling through. What was missing from this denominator, by the way? This one has it all, but this one's missing the x plus 5. So I'm going to multiply the top times the x plus 5 it was missing. And then in the denominator, what would be the nicer way for us to write the common denominator if we're going to be using that in just a second? Do we want to write it all factored out? Well, you can use that trick when you're actually adding or subtracting. But doesn't x plus 5 times x minus 5 equal x squared minus 25? Right. So you guys can write it out in the factor form if you want to, but eventually you're going to have to FOIL anyway in order to continue with the question. So I like to just write it in its already FOILed form, since we knew what that was going to be from the other fraction. Just some things you guys can use for shortcuts. If you like to go the long way because it makes more sense, that's perfectly fine. Alright, so if I'm going to be adding these two together, you're going to have to distribute the x throughout this so you can add the pieces together because you want to combine like terms. So if I distribute the x, nice, and then plus 5x, and then I'm also adding the, subtracting the 17 onto that. So I'd have minus 17 over my and then equals. Do I have anything to worry about for the one side over here? No?
No.
Okay. So this one I'm going to show you guys a shortcut. This one's a little bit complicated. What would you do from here using the process that we were doing before? You cross multiply, but what would that have you doing? You would have a binomial times a trinomial, which is something we've done before. We know how to do an extended distribution, but that's a little iffy. So for this one, do you guys have space underneath? In the space underneath the box, I'm going to show you guys a shortcut you guys can use. So this was what I asked you guys to cross out from the top because it's a little bit more complicated, but it's actually more helpful if you have an already super complicated question. So what you guys can do is have LCD on both sides of the equal sign. So make both sides of the equal sign have the common denominator, and then only work with numerator. Only work with, that's a W, numerator. So if you get a super complicated question like this, where you would have to multiply a binomial times a trinomial, that's crazy, you guys could just get the common denominator on both sides and then work with only the numerator. So if we do that, what does the common denominator have to be again? The x squared minus 25, which was the x plus 5, x minus 5. So to get this to look like that, what would I have to multiply that by?
X minus 5.
Yep. And again, these ones are more complicated, so you're not going to see these ones, I would imagine. But our first fraction would look like this. 17. And then our second fraction, if I multiply the top times the x minus 5, there's only a 1 there originally. So what would the numerator have? What's 1 times x minus 5? Once you have the common denominator, you can ignore the fraction. Ignore the denominator. We already know that x squared minus 25 is in both fractions, so you can completely erase the denominator. You don't even need it anymore. Once you have the common denominator on both sides of the equal sign, we're only going to work with the numerator now. Bless you. So now we just have this. You can circle it for a second so it stands out. Right? This is what I'm going to be solving. How would I solve that? Move the x and the 5 over.
Oh my god.
Just not like that. Yikes. What? Drew's gonna fix it?
She has no confidence.
So you'd have x squared plus 4x minus 12. Right? And we're not gonna have time to finish, but you would factor to solve. X lets us see, and your answers would be -6 and 2. -6 and 2. Sorry, we don't have time to finish it. But the restrictions came from the common denominator, so 5 and -5. 5 and -5 would be restrictions. So rare, but in case you see that, you can use that little shortcut method.